The following activity uses common household items such as cornstarch and glue that are quite safe to use, but you should not eat your creation. This activity should be done only under the supervision of an adult.
Okay, hi, I'd like to talk today about big molecules and how you can link them together and make something fun called slime or gloop or oobleck, and maybe you've made it before in class, but we're going to make it again today. We're going to make something. Anyway, Elmer's glue has this chemical structure. It's polyvinyl alcohol, and it's a long molecule with a bunch of these OH groups on it. Pay attention to the OH. When you have long molecules, they can move, right, together. They can move around, I guess, each other. And you can see my Elmer's glue. This is Elmer's glue in here. And it's liquidy, right? It moves around. Okay. If I add boric acid, like I might have in contact lens solution, I can get the OHs that are here in the boric acid to kind of displace or interact with the OHs that are here in the molecule on the polyvinyl alcohol. And I can start, instead of having free movement between those molecules, I can start forming bonds. And that makes them more rigid. So let's take a look at what that looks like. So I've got my Elmer's glue, and I'm going to add a teaspoon of sodium bicarbonate. This is like you might find in your kitchen. You put it in cookies and stuff. And I'm going to add that in here. And I don't know if you can tell, it's gotten a little bit thick and clumpy. The sodium bicarbonate will link the molecules up a little bit. I'm going to add a little bit, teaspoon of water, but you can see it's still kind of mostly like Elmer's. So that was a tablespoon of Elmer's glue with a teaspoon of bicarbonate, and I'm going to add a teaspoon of water and mix that up. And you can see, right, what it looks like and how thick it is. Still really liquidy. Now I'm going to add about 10 drops of this contact lens solution. And I'm going to keep stirring it. Can you see that it has changed? I mean, almost immediately, right? Okay. That will continue to kind of thicken over time. And I can show you one that I made a couple hours ago. And what's happening is those chemical bonds between the boron and the polyvinyl alcohol are happening. And so you can see that this one that I made a couple hours ago is much more solid. Okay. Now let's try this again, but with another compound. So same idea. We've got big molecules moving together. That would be cornstarch, right? And these are long molecules of glucose. And we're going to add in some water. And what happens is, well, let me get my cornstarch and a container for mixing. And my ratio here, so here's my container, is 2 parts of cornstarch, and the cornstarch, right, like you have in your kitchen. 2 parts cornstarch. And you have a container of cornstarch that looks like this. So I've got, there's my cornstarch. And the water, the amount of water I need is a little bit variable, but generally I need twice as much cornstarch as water. So I've got my water over here. I'm going to see if I can make one bit of water work. And I don't, you can't, well, it's kind of solid, right? There's not a lot of water here. This is pretty solid. So I'm going to try to add just a little bit more water because it's really easy to overdo with the water. Let's see see if I can get just a little bit more water. This is like a half a spoon, and I'm going to just add a couple drips. I could add food coloring at this point. And some of the, oh, I'm making a mess. I hope you're working over an easy place to clean up. You should be in the kitchen or something. This is still pretty solid, so I'm going to get some more water. And this is a lot about patience. So we'll see how quickly we can be patient. Can you be quick and be patient? I don't think so. Okay. Yeah, this is looking right. Can you see I'm having a little bit of trouble stirring it? And I'm trying to get, because my cornstarch is kind of stuck on the side of the container. And can you see it's sort of goopy now? It's definitely getting thicker. Okay, so this is something that you're going to play with. You probably don't want to add all your cornstarch in one go, just in case you had too much water and you need to thicken it back up again. And so rather than make you watch me do this, I'm going to pull out the one that I made earlier. And you can see it's kind of semi-solid. When I put pressure on it, it's really solid, and I can even break off chunks of it. Okay, so there it is, being super liquidy, but you saw me just a minute ago trying to pry it out of the container. When it's under pressure, so when you push down on it, it's really hard and solid. And when you just let it flow, you can see that it's dripping. And so what's going on there is that you've got these large molecules of cornstarch, and there's water in between them when it's liquidy. But when you push down, you squish all the water out, and then you only have the cornstarch interacting with itself. And so if you want to add food coloring, then yours could be blue too. But you can see that it goes from solid to liquid depending on how hard I'm pushing on it. And this is called a non-Newtonian fluid. And you can, yeah, you can look that up if you want to see more, but it's about the water molecules in between the cornstarch molecules. This stuff, okay, so once you've made this, you can put it back in the container, put the lid on it, and have it for maybe a day or so, but if you leave it around for too long, it gets kind of moldy and messy. So maybe this is good to play for a day or so. So I hope you enjoy it, and I hope you have a great SciFest.